So, we have seen that glucose, galactose and fructose, these are absorbed through the intestine and they are released into the blood through transporters called as GLUTs or glucose transporters. We require glucose 2 transporters which are present inside the intestine, which will transport all these sugars inside the blood. We have seen how glucose is metabolized through glycolysis, both aerobic and anaerobic, and also a part of fermentation. Now, we will see how fructose is getting metabolized. Fructose very similar to our hexokinase, there is a enzyme inside the body that is fructokinase. This fructokinase, it will add a phosphate group to fructose utilizing ATP and converts it into fructose phosphate. Okay, now fructose takes one phosphate and forms fructose 1-phosphate. This in presence of aldolase-B enzyme. Aldolase-B enzyme is broken down to glycerol 3-phosphate and dihydroxyacetone phosphate. Glycerol 3-phosphate and dihydroxyacetone phosphate. If you remember, in glycolysis, glucose was converted to glucose 6-phosphate, which was converted to fructose 6-phosphate, which was converted to fructose 1,6-bisphosphate. That fructose 1,6-bisphosphate was broken down into glyceraldehyde 3-phosphate. Here it is glycerol. This is an alcohol, that was an aldehyde. Glyceraldehyde 3-phosphate. Okay. So, here it is forming glycerol 3-phosphate. The enzyme there was aldolase-A, here it is aldolase-B. Okay. Now, this glycerol 3-phosphate gets converted to glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate in presence of triose kinase. This step requires a ATP. Okay. Dihydroxyacetone phosphate, as in glycolysis, in presence of triose phosphate isomerase. We have talked yesterday that triose phosphate isomerase is a catalytically perfect enzyme. Okay, its catalysis is very fast. So, what happens is this dihydroxyacetone and glyceraldehyde 3-phosphate, we have seen that they are totally interconvertible. Okay. Now, this glyceraldehyde 3-phosphate goes into glycolysis and produces pyruvate. All right. What has happened here? Fructose takes a phosphate from ATP in presence of fructokinase to form fructose 1-phosphate. This fructose 1-phosphate breaks down to dihydroxyacetone phosphate and glycerol 3-phosphate. Then this glycerol 3-phosphate forms glyceraldehyde 3-phosphate using triose kinase. This glyceraldehyde 3-phosphate will go into here glycolysis. Dihydroxyacetone phosphate and glyceraldehyde 3-phosphate, these are isomerases, that is aldo-keto isomerases, and they get interconverted very fast based on the amount of ATP that is present inside the body. If more amount of ATP is there, then dihydroxyacetone phosphate, yesterday we have seen that it will form glycerol 3-phosphate. And this glycerol 3-phosphate will go and form fat. Alright. If ATP is less, then glyceraldehyde 3-phosphate will go and form your pyruvate. Alright. Now, here at this step there is minus 1 ATP, at this step there is minus 1 ATP. From glyceraldehyde to pyruvate, yes, we have seen that 5 ATP are produced from 2 NADH, alright, 1 phosphoglycerate kinase reaction, so 2 into 1 ATP, that is 2 ATPs, and 1 pyruvate kinase reaction, that is 2 into 1 ATP, which is 2 ATP. So, a total of 9 ATPs are formed from glyceraldehyde to pyruvate. 9 minus 1 is minus 2. So, the net production of ATP is again 7. Very similar to our aerobic glycolysis, there is not much change. Okay. So, even in fructose metabolism, even if fructose gets metabolized, then we get 7 ATPs. Alright. But still, fructose is not a substrate of choice for glycolysis. Fructose almost always goes into fat production. You need to remember that dictum. Alright. Now, there are two disorders associated with fructose metabolism. One is essential fructoseuria. If phosphofructokinase is deficient, then it will lead to essential fructoseuria. Then it will lead to essential fructoseuria. If aldolase-B is deficient, what happens is there is increased production of fructose 1-phosphate or increased accumulation of fructose 1-phosphate, okay, aldolase-B. What happens is fructose 1-phosphate cannot be broken down further. So, fructose 1-phosphate gets accumulated inside the body and it will lead to hereditary fructose intolerance. Hereditary fructose intolerance. It will lead to hereditary fructose intolerance. So, that is about fructose metabolism that you need to remember for your exams or for your career. Fructose breaks down to fructose 1-phosphate, which forms glycerol 3-phosphate and dihydroxyacetone phosphate. This glycerol 3-phosphate again forms a glyceraldehyde 3-phosphate in of triose kinase. Okay. This glyceraldehyde will finally enter the glycolysis and it will produce pyruvate. Net production of ATP is 7 in fructose metabolism. 2 inborn errors of metabolism are seen. One is essential fructoseuria, whereas there is no symptoms, only the accumulated fructose, because fructose cannot be metabolized. It generally is seen in urine. Urine you will get reducing sugar positive. Okay. So, that is seen in essential fructoseuria, not many symptoms, okay, no symptoms at all. Hereditary fructose intolerance, because fructose 1-phosphate gets accumulated, these people they have symptoms. Okay. What happens is they cannot tolerate fructose anymore, like your honey, especially happens when you are weaning the child. When do you wean the child? We wean the child when the child is around like 6 months. Okay. So, what generally in our households what we do, we keep a ceremony for that, or some people do not do that, but the starting diet will be honey. You feed the child honey. So, what happens is like during that function or season, what we do is first the grandfather will come and put some honey on the child's tongue. So, the child suckles it and it's really happy and it's cooing around. So, what happens, everyone thinks that the child is really liking honey. So, what happens is after that the grandmother comes, oh, he's liking honey, oh so cute. Then she also puts some honey in her mouth. Then the father will keep, then the mother will keep, then aunt will keep, then uncle will keep, then postman will keep, then milkman will keep. Finally, the dog will also come and keep some honey in the baby's mouth. So, even if the child is not fructose intolerant, he will still start puking out. Correct or not? Same way, in hereditary fructose intolerance, what is happening is when you start weaning the child, when you give the child a fructose diet and he cannot metabolize that, fructose 1-phosphate starts getting accumulated, baby won't be able to tolerate it. So what he'll do is he'll start throwing up. Okay, the baby is vomiting all that, he's having loose motions, he's having abdominal cramps, pain, he's really irritable, crying, shouting that he doesn't want that fructose diet, and you still keep feeding the child with the fructose diet. So what happens is finally this child, he'll go into hypoglycemia. Why? Because he's not taking the diet, everything whatever is coming inside he's puking out. Okay, so he'll go into hypoglycemia, finally he may go into hypoglycemic coma also, and can be mortal also if we don't recognize it early and treat it early. Okay, so that is about fructose metabolism.